In this video, we're going to learn how to find the real zeros given the vertex form of a function, as well as review a few things such as transformation, but just very briefly. So we need to remember vertex form, and that this is written in vertex form. And vertex form is we have some function, and then we have a times x minus h cubed plus k. So this is vertex form, where h and k is our vertex. So in this case, our vertex is 1 4/3. That would be our vertex. But we're not asking to transform anything. We're asking to find the real zeros. So what we need to understand or remember is what this word zeros mean. So zeros, when we're looking for the zeros, that means the place where y equals 0, which is also our x-intercept. So again, we have to remember the vocabulary. So if y equals 0, then that simply means in this equation we're going to substitute y with 0. So let's rewrite this equation. So it's going to be 0 is equal to 9/2 x minus 1 cubed plus 4/3. Okay, so we're solving for x. X is in one place. Let's see where x is right now. Well, x is in jail. I haven't used that term in a long time. But x is in jail because it's with this, it's being cubed right now. So right now x is in jail, so I'm going to put it in jail, which means I need to get rid of everything outside the jail before I can free the x. So when I'm looking here, I have 9/2 times this plus 4/3. So the easiest thing to get out of there first is whatever we're adding or subtracting. So that means in this case, I'm going to subtract 4/3 from each side. I'm going to leave it as a fraction because it actually is going to work out to my benefit if I do. So this means now I have negative 4/3 is equal to 9/2 times my jail. So I don't really care what's in there right now because it's in jail. But I'm going to go ahead and write this in just so that you see that's still there. It's in jail. So there's less happening outside the jail. So what's happening right now? I have 9/2 times this thing, so I have to untimes it. I don't want to divide because dividing, this is what dividing would look like. If I had 9/2, I would then have to divide it by 9/2, and then that would look, that's pretty ugly over on this side, because and that means then, I'm going to put this little jail over here, then that means on this side I would have negative 4/3, and I would have to divide that by 9/2, and this here is just ugly. Okay? So it's easier if I multiply this by the reciprocal or inverse. So I'm going to multiply by reciprocal, otherwise known as the multiplicative inverse, which is 2/9. So what I do to one side, I have to do to the other. So that means then on my left side, there's nothing I can simplify here. So I'm going to just multiply 2 times negative 4. I get negative 8. 9 times 3, I get 27. This by design right here, this by design ended up dividing out to 1. So then I'm just left with my jail. But since everything's gone from outside the jail, I can just write the quantity of x minus 1 cubed. So already it's looking much easier to do. So I have to remember that the inverse operation of cubing is the cube root. So that means now I need to take the cube root of both sides. I'll take the cube root of both sides of that equal sign. So we did this because cube root undoes a cube, so that means on my right side I have x minus 1. And now here I'm going to break this up to be the cube root of -8 divided by the cube root of 27. So I sometimes have to know when to divide first and then take the cube root, or when to break the cube root into two different parts. I recognize 8 is a perfect cube and 27 is a perfect cube, so I did it like this. So the cube root of -8 is -2, and the cube root of 27 is 3, and that equals x minus 1. So you can see I'm almost done. So now I just have to add 1 to both sides of the equation. 1 minus 2/3 is 1/3. So that's what x equals. So that's the mathematical way of finding the real zero. So remember, there are actually more roots, but we haven't been asked to find them. So if I were to, I'm going to rewrite this just for review. I'm going to rewrite the original. And so this here means that I have 3 roots, and this means here, that's 3 roots, and then I have 1 real root, which means then I must have 2 imaginary roots. Okay, but this is getting outside of what the question was asking. It just asked me to find this. Now there was a quick and easy way to do this, because it's just asking for the real root. So that means then that I would just put my equation in my calculator,